The rebel who reimagined reality. The story of Albert Einstein. Prologue. The question that changed everything. Imagine being 16 years old, lying in a field, staring at the sky, and asking yourself a question so profound it would unlock the secrets of the universe. What would it be like to ride on a beam of light? Most teenagers wonder about far simpler things. But Albert Einstein was never most teenagers. That single thought experiment, that one impossible question, set him on a path that would shatter our understanding of space, time, matter, and energy. It would reveal that the universe is far stranger, far more beautiful, and far more mysterious than anyone had ever imagined. This is the story of the man who proved that time is relative, that energy and matter are interchangeable, that gravity bends the fabric of space itself. But more than that, this is the story of a rebel, a dreamer, a patent clerk who dared to question everything the greatest minds in history had accepted as absolute truth. This is the story of how one man's imagination became humanity's reality. Chapter 1. The Boy Who Wouldn't Speak. On March 14, 1879, in the city of Ulm, Germany, Pauline Einstein gave birth to a son with an unusually large, misshapen head. The doctors assured her it would normalize, but Pauline worried. Her concern deepened when young Albert didn't speak. 2 years old, then 3, then 4, still silent. His grandmother called him far too fat. His parents feared he might be intellectually disabled. The family mate called him the dopey one. But Pauline saw something others didn't. She saw the intensity in her son's eyes as he watched the world, processing, thinking, understanding in ways that had nothing to do with words. When Albert finally spoke, it wasn't in baby talk or simple sentences. He would formulate complete thoughts in his mind first, whispering them to himself to test them out, and only then would he speak them aloud. He was teaching himself precision of thought before precision of speech. At age 5, Albert was sick in bed when his father brought him a gift, a simple magnetic compass. Albert stared at it, mesmerized. The needle always pointed north, no matter how he turned the case. Something invisible was acting on that needle. Something he couldn't see or touch was exerting force across space. In that moment, young Albert experienced something that would define his entire life. The profound sense that beneath the visible world lay hidden realities governed by elegant, invisible laws. He later said that the compass gave him a deep and lasting impression, and that something deeply hidden had to be behind things. The boy who wouldn't speak had found his calling. He would spend his life uncovering what was hidden. Chapter 2. The Rebel Student. Albert's parents enrolled him in a Catholic elementary school in Munich, where he was the only Jewish student. He hated it. The rigid, military-style discipline of German education felt like a prison to his free-spirited mind. Students were expected to memorize and recite, not to question or explore. Teachers demanded obedience, not curiosity. Young Albert rebelled in the only way he knew how, by withdrawing into his own thoughts. His teachers found him insolent and difficult. One teacher told him, "You will never amount to anything, Einstein." The headmaster suggested he leave school because his mere presence destroyed other students' respect for their teachers. But at home, Albert's mind flourished. His uncle Jacob introduced him to algebra, calling it a merry science, where you hunt for an unknown animal called X. Albert fell in love with the puzzle of it. Max Talmud, a poor medical student who dined with the Einstein family weekly, brought Albert popular science books that opened doorways to geometry, philosophy, and physics. At age 12, Albert encountered Euclid's geometry and experienced what he later called wonder of a totally different nature from the compass. Here was pure thought, pure logic, building absolute truths from simple axioms. He worked through the entire book on his own, proving theorems before reading the proofs. The certainty and elegance of mathematics captivated him completely. But as Albert's intellectual world expanded, his formal education remained suffocating. When his family's business failed and they moved to Italy, 15-year-old Albert was left behind in Munich to finish school. Miserable and alone, he did something audacious. He obtained a medical certificate claiming nervous exhaustion and quit school without a diploma. He showed up at his family's doorstep in Italy, unemployed and without credentials. His father was furious. His future seemed hopeless. Albert didn't care. He had escaped his prison. Chapter 3: The Dreamer in Switzerland. Albert applied to the Swiss Federal Polytechnic in Zurich, one of Europe's finest technical schools. He failed the entrance exam. His mathematics and physics scores were excellent, but his knowledge of languages, biology, and other subjects was abysmal. The director, impressed by his physics scores, suggested he complete his secondary education and try again. Albert enrolled at a progressive school in Aarau, Switzerland, and for the first time in his life, he loved learning. The school emphasized visual understanding and independent thought rather than rote memorization. Here, in this environment of intellectual freedom, 16-year-old Albert conducted his famous thought experiment. What would the world look like if you could ride alongside a beam of light? According to the physics of the day, you should see the light wave frozen in space, stationary. But this seemed paradoxical, impossible. This question, this apparent contradiction, planted a seed that would take 10 years to fully bloom into the special theory of relativity. In 1896, Albert passed his exams and entered the Polytechnic. He was free to study physics at one of the best schools in Europe. He should have been ecstatic. Instead, he was frustrated. The curriculum was outdated, ignoring the revolutionary discoveries happening in physics. The professors lectured from old notes about old ideas. So Albert stopped attending most lectures. He spent his time in cafes, reading the latest papers by Maxwell, Boltzmann, and Lorentz, educating himself on the cutting edge of physics while his professors droned on about the past. He relied on his friend Marcel Grossmann's meticulous lecture notes to pass exams. His professors were not impressed. Heinrich Weber, his physics professor, told him, "You're a smart boy, Einstein. But you have one great fault. You do not let yourself be told anything." It was true. Einstein had learned something crucial. Authority and truth are not the same thing. Just because everyone believes something doesn't make it true. Just because it's written in a textbook doesn't make it sacred. Everything can be questioned. Everything should be questioned. This independence of thought would prove to be both his greatest strength and his greatest obstacle. Chapter 4: Love and Struggle. At the Polytechnic, Albert met the only woman in his physics program, Miliva Maric, a brilliant Serbian student with a limp from childhood tuberculosis. She was intense, intellectual, and shared his passion for physics. They fell in love over differential equations and debates about the nature of light. Albert's mother was horrified. Miliva was older, Serbian, not Jewish, and worst of all in Pauline's eyes, too intellectual. "By the time you're 30, she'll be an old witch," Pauline warned. But Albert didn't care. In Miliva, he had found someone who understood his mind, someone he could talk to about the ideas that consumed him. After graduation in 1900, Albert's future looked bleak. His independence and frequent absences from class meant his professors wouldn't recommend him for academic positions. He was the only graduate from his class who didn't receive a university appointment. While his classmates began their careers, Einstein was unemployed, desperate, and growing bitter. He survived on temporary teaching positions and private tutoring, barely scraping by. Meanwhile, Miliva became pregnant. In 1902, she gave birth to a daughter, Liesel, in secret at her parents' home in Serbia. The baby's fate remains one of history's mysteries. She either died young or was given up for adoption. Albert may never have even met his first child. These were dark years. Einstein's father died in 1902, his last words to Albert a plea to take care of the family. Albert felt the weight of failure crushing him. He was 23 years old, with no job prospects, a secret child, family expectations, and a mind bursting with revolutionary ideas that no one would listen to. But then, through Marcel Grossmann's father's connections, Einstein landed a job at the Swiss Patent Office in Bern as a technical expert, third class. It seemed like a dead end, a surrender of his dreams of becoming a physicist. It turned out to be the perfect laboratory for genius. Chapter 5: The Miracle Year. The patent office job was ideal for Einstein's particular brand of genius. The work examining patent applications was stimulating enough to keep his mind engaged but mechanical enough that he could do it efficiently, leaving time for his own thoughts. He called his desk at the patent office, My Theoretical Physics Bureau in Hiding. Einstein would finish his patent work quickly, then pull out his own papers and calculations, hastily hiding them in a drawer whenever footsteps approached. He was supposed to be examining patents for electromagnetic devices. Instead, he was reimagining the fundamental nature of reality. In his small apartment with Mileva, they had married in 1903, discussing ideas with him and their infant son Hans Albert sleeping nearby. Einstein worked on problems that had haunted him for years. He had no laboratory, no research team, no university resources. He had only his mind and an unshakable conviction that the universe made sense, even if that sense contradicted everything the experts believed. 1905 became his miracle year, his annus mirabilis. Between March and September, while working full-time at the patent office, 26-year-old Albert Einstein published 4 papers that would change physics forever. The first paper explained the photoelectric effect, the way light knocks electrons off metal surfaces. Einstein proposed something radical: light, which everyone knew was a wave, also behaved like particles. He called them light quanta, later named photons. This paper, More Than Relativity, would eventually win him the Nobel Prize. The second paper proved the existence of atoms and molecules by explaining Brownian motion, the random jittering of tiny particles suspended in fluid. At the time, many respected scientists still doubted atoms existed. Einstein's mathematical analysis proved they were real. The third paper introduced the special theory of relativity. Einstein showed that space and time are not absolute and unchanging as Newton had believed. Instead, they are relative, flexible, intertwined. Time passes differently for objects moving at different speeds. Space itself contracts at high velocities. The only constant in the universe is the speed of light. The paper was revolutionary not just in its conclusions but in its method. Einstein didn't conduct complex experiments. He simply thought deeply about the logical consequences of 2 simple principles. The laws of physics are the same for all observers moving at constant speeds, and the speed of light is constant for all observers, regardless of their motion. From these 2 principles, using only thought and mathematics, Einstein dismantled 300 years of Newtonian physics. The fourth paper, published as an afterthought in September, was just 3 pages long. It contained the most famous equation in history, equals mc squared. Energy equals mass times the speed of light squared. Mass and energy are interchangeable. They are different forms of the same thing. A tiny amount of mass contains an enormous amount of energy. The equation that would eventually unlock both nuclear power and nuclear weapons came from a patent clerk in Switzerland, scribbled as an afterthought to a paper about relativity. For papers, 6 months, the entire foundation of modern physics. And almost nobody noticed. Chapter 6, The Long Wait. Einstein sent his papers to Annalen der Physik, the most prestigious physics journal in Germany, and returned to examining patents. He expected his papers to cause an immediate sensation. They didn't. The scientific community was conservative, skeptical, and dismissive of unknown patent clerks making extraordinary claims. Most physicists simply ignored the papers. Those who read them were confused or hostile. Relativity contradicted common sense and intuition. It challenged the work of the greatest minds in history. Who was this nobody claiming that Newton was wrong? Einstein waited and waited. He continued working at the patent office. He continued doing physics in his spare time. He wondered if he would spend his entire life as a patent clerk, his revolutionary ideas dying in obscurity. Slowly, very slowly, a few physicists began to understand what Einstein had done. Max Planck, one of the founders of quantum theory, recognized the importance of relativity and began lecturing about it. Young physicists started citing Einstein's work. The tide was turning. In 1908, Einstein finally received his first academic appointment, a low-level position at the University of Bern. The salary was so poor he kept his patent office job. But he was lecturing at a university. He was finally being recognized as a physicist. By 1909, recognition was spreading. Universities competed to hire him. Einstein, who couldn't get a teaching position 8 years earlier, suddenly had his choice of prestigious appointments. He chose the University of Zurich, then Prague, then the ETH Zurich, climbing the academic ladder with astonishing speed. But Einstein's personal life was crumbling. The partnership he'd once shared with Mileva had soured. She grew resentful of his obsession with physics, his emotional distance, his growing fame. Einstein, brilliant at understanding the cosmos, was terrible at understanding the human heart. Their marriage became cold, hostile, a prison for both of them. Einstein found warmth elsewhere, in his cousin Elsa, a divorcee who lived in Berlin. The affair deepened his estrangement from Mileva. But Einstein's emotional turmoil couldn't stop his mind from working on the problem that consumed him, gravity. Chapter 7. The Happiest Thought. In 1907, while still at the patent office, Einstein had what he called the happiest thought of my life. He imagined a man falling from a roof. During the fall, the man wouldn't feel his own weight. He would be weightless, floating as if gravity had ceased to exist for him. This simple thought experiment revealed something profound. The effects of gravity and the effects of acceleration are indistinguishable. A person in an accelerating elevator feels pushed to the floor just as if gravity were pulling them down. A person in free fall feels no gravity at all. Einstein realized that gravity wasn't a force in the traditional sense. It was something else entirely, a curvature of space and time itself. Massive objects like the sun don't pull on the Earth across empty space. They warp the fabric of space-time, and the Earth simply follows the curves in that fabric, like a marble rolling in a curved bowl. For 8 years, Einstein struggled to develop this insight into a complete theory. He needed mathematics he didn't know, tensor calculus, differential geometry, concepts far beyond what he'd learned in school. He turned to his old friend Marcel Grossmann, now a mathematician, for help. The work was agonizing. Einstein later said, "In all my life I have not labored nearly so hard, and I have become imbued with great respect for mathematics, the more subtle parts of which I had previously regarded as sheer luxury." He made mistakes, published incorrect versions, backtracked, tried again. His marriage collapsed completely. World War I erupted around him, and while his colleagues wrote patriotic manifestos supporting Germany's militarism, Einstein courageously signed an anti-war petition, making himself deeply unpopular. But he kept working on gravity. In November 1915, Einstein presented his complete general theory of relativity to the Prussian Academy of Sciences in Berlin. It was the most beautiful theory in the history of physics, an elegant set of equations describing how matter and energy curve spacetime, and how curved spacetime tells matter and energy how to move. Einstein was so certain of its beauty and truth that he famously said if experiments disagreed with the theory, he would feel sorry for God because the theory is correct. The theory made specific, testable predictions. Most dramatically, it predicted that light from distant stars would bend when passing near the sun. The bending would be exactly twice what Newtonian physics predicted. But there was a problem. You can only test this during a total solar eclipse, and World War I made scientific expeditions impossible. Einstein would have to wait. Chapter 8. Eclipse and Immortality. On May 29, 1919, a total solar eclipse crossed the Atlantic Ocean. 2 British expeditions, one to Sobral, Brazil, and another to the island of Principe off the coast of Africa, set out to photograph stars near the sun during totality. The leader of the expeditions was Arthur Eddington, a brilliant astrophysicist determined to test Einstein's outrageous claim. Einstein waited anxiously in Berlin. Germany had lost the war. The country was in chaos, gripped by revolution and starvation. Einstein's personal life was in shambles. He had divorced Mileva and married Elsa, but the transition had been bitter and painful. He was separated from his sons. Everything in his life was uncertain. Everything except his theory. Einstein knew it was right. On September 22, 1919, Einstein received a telegram from Hendrik Lorentz. Eddington found star displacement at rim of sun, preliminary measurement between 9/10 of a second and twice that value. Einstein's prediction was 1.7 seconds of arc. Eddington's measurements matched almost perfectly. General relativity was confirmed. On November 6, 1919, the results were formally announced at a joint meeting of the Royal Society and the Royal Astronomical Society in London. The president of the Royal Society called it one of the highest achievements of human thought. The Times of London ran the headline, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." Overnight, Albert Einstein became the most famous scientist in the world. He woke up to find photographers camped outside his apartment. Newspapers everywhere ran his photograph. The wild-haired physicist who had overthrown Newton, who had proven space and time were not what they seemed, who had shown that reality itself was stranger than fiction. Einstein was bewildered by the celebrity. He joked, "The cult of individual personalities is always wrong. Yet it is even more wrong to let oneself be burned by it." But the world needed a hero. After the horror of World War I, after millions dead in the trenches, after empires collapsed and civilization seemed to have destroyed itself, the world needed to believe in something pure, something beautiful, something transcendent. Einstein's gentle genius, his wild hair, his pacifist principles, his Jewish identity surviving in Christian Europe, he became a symbol of hope. And Einstein, who had never sought fame, who wanted only to understand the universe, found himself a reluctant icon. Chapter 9. The Quantum Debate. Einstein's fame grew throughout the 1920s. He traveled the world, lecturing, meeting presidents and artists, philosophers and musicians. He played violin in impromptu concerts. He sailed his small boat on quiet lakes. He wore the same leather jacket for years, refused to wear socks, and let his hair grow wild because he hated barbers. But beneath the public persona of the absent-minded genius, Einstein was engaged in a profound intellectual struggle that would define the rest of his life. Quantum mechanics, the physics of atoms and subatomic particles, was developing rapidly. Young physicists like Werner Heisenberg, Niels Bohr, and Wolfgang Pauli were discovering that at the quantum level, reality was fundamentally probabilistic. You couldn't predict exactly what an electron would do, you could only calculate probabilities. More disturbing, the act of observation itself seemed to affect reality. Until you measured a particle's position, it existed in a fuzzy state of probability, in multiple places at once. Measurement collapsed this probability into a definite state. Einstein hated it. Not because he didn't understand it, he understood it perfectly, better than almost anyone. He hated it because it violated his deepest intuition about the nature of reality. Einstein believed the universe was fundamentally deterministic, governed by precise laws. Quantum mechanics seemed to say the universe was fundamentally random, governed by dice-throwing chance. God does not play dice with the universe, Einstein famously declared. Niels Bohr responded, "Einstein, stop telling God what to do." For years, Einstein engaged in friendly but fierce debates with Bohr and the quantum physicists. He devised thought experiments designed to show contradictions or absurdities in quantum theory. Each time, Bohr found flaws in Einstein's reasoning. The debates were intellectual combat at the highest level, two titans of physics fighting over the nature of reality itself. In 1935, Einstein and two colleagues published the EPR paradox, named for Einstein, Podolsky, and Rosen, which seemed to prove that quantum mechanics was incomplete. If quantum mechanics was correct, Einstein argued, then measuring one particle could instantaneously affect another particle across the universe. Spooky action at a distance that violated relativity's speed limit. Einstein thought this proved quantum mechanics must be wrong or incomplete. He was wrong. Experiments decades later proved that quantum entanglement is real. The spooky action at a distance happens. Reality is indeed as strange as quantum mechanics claims. But Einstein never accepted it. The man who had revolutionized physics by overturning Newton's absolutes now found himself in Newton's position, a conservative defender of determinism while younger physicists rushed toward a new vision of reality. It was a profound irony. The rebel had become the establishment he once rebelled against. Chapter 10. The Refugee. In 1933, Einstein was visiting America when Adolf Hitler came to power in Germany. Einstein, Jewish and pacifist, had long been a target of Nazi hatred. They burned his books, confiscated his property, and put a bounty on his head. Returning to Germany meant certain death. At age 54, Einstein became a refugee. He accepted a position at the newly founded Institute for Advanced Study in Princeton, New Jersey. The small college town became his home for the rest of his life. He lived in a modest house on Mercer Street, walked to his office every day, and became a fixture of the town, the old man with wild white hair who would chat with children on the street and help them with their homework. But Einstein's heart was heavy. The world was sliding toward another catastrophic war. His beloved Germany, the land of Goethe and Beethoven, had embraced evil. His extended family in Europe was in danger. The horror of it haunted him. Then, in 1939, physicist Leo Szilard came to Einstein with terrifying news. Nuclear fission had been discovered. It was possible to create a bomb of unprecedented destructive power using Einstein's equation equals mc squared. If Nazi Germany developed such a weapon first, they could conquer the world. Szilard drafted a letter to President Franklin Roosevelt warning of this danger and urging America to begin its own atomic weapons program. He needed Einstein's signature to give the letter weight. Einstein signed it. It was one of the few decisions he would later deeply regret. The Manhattan Project was born, eventually creating the atomic bombs dropped on Hiroshima and Nagasaki. Einstein played no role in the actual development of the bombs. The government denied him security clearance because of his pacifist views. But his equation made it possible, and his letter helped start the project. When Einstein heard about Hiroshima, he was devastated. "Woe is me," he said simply. For the rest of his life, Einstein became an advocate for nuclear disarmament and world government. He used his fame to warn humanity about the dangers of the weapons his science had made possible. "The unleashed power of the atom has changed everything save our modes of thinking," he wrote, "and we thus drift toward unparalleled catastrophe." Chapter 11. The Unified Dream. In Princeton, Einstein continued working, but not on quantum mechanics or new discoveries. He devoted the last 30 years of his life to a seemingly impossible quest, finding a unified field theory that would combine gravity and electromagnetism into a single, elegant mathematical framework. He believed deeply that the universe was governed by a simple, beautiful underlying principle. If he could just find the right equations, everything would fit together perfectly. Gravity, electromagnetism, the forces of nature, all would be revealed as aspects of one fundamental reality. His colleagues thought he was wasting his time. Physics had moved on. Quantum mechanics was producing spectacular discoveries. New particles were being discovered in accelerators. The future of physics was in the quantum realm, not in Einstein's classical unified theories. But Einstein didn't care. He had never followed the crowd. He worked alone in his office, filling page after page with equations, searching for the pattern, the key, the answer. He never found it. The problem was deeper than even Einstein realized. He was trying to unify gravity and electromagnetism, but nature had more forces than he knew, the strong and weak nuclear forces, not discovered until later. And any successful unified theory would have to incorporate quantum mechanics, which Einstein refused to accept. He was chasing a dream with incomplete information and self-imposed restrictions. It was doomed from the start. But was Einstein really failing? Or was he simply decades ahead of his time again? Today, physicists are still searching for the unified theory of everything that Einstein dreamed of. String theory, loop quantum gravity, other exotic proposals, they're all pursuing Einstein's vision. The quest he began remains the holy grail of physics. Perhaps Einstein wasn't chasing an impossible dream. Perhaps he was just born too soon to catch it. Chapter 12. The Human Einstein. Away from physics, Einstein was a man of simple pleasures and deep contradictions. He loved sailing his small boat, though he never learned to swim and frequently capsized. He played violin, badly, according to some who heard him, beautifully according to others who were more charitable. He loved Mozart and maintained that death means you can't listen to Mozart anymore. He was kind to children and strangers, generous with his time, always willing to answer letters from curious students. He used his fame to support causes he believed in: civil rights, nuclear disarmament, academic freedom. When Marian Anderson, the great black contralto, was denied a hotel room in Princeton because of her race, Einstein invited her to stay in his home. They became lifelong friends. But Einstein was terrible at personal relationships. His second marriage to Elsa was more companionship than passion. When she died in 1936, he mourned, but without the deep grief others might have felt. His relationships with his sons were complicated and often distant. Hans Albert became an engineer and had a respectful but not close relationship with his father. Eduard, his younger son, suffered from schizophrenia and spent most of his adult life in psychiatric institutions. Einstein visited when he could but found his son's illness deeply painful and bewildering. Einstein had affairs, including a long relationship with a woman named Margarita Konenkova who may have been a Soviet spy. His personal life was messy, human, flawed. In his later years, Einstein became something of a sage, a symbol of wisdom and humanistic values. People wrote to him seeking advice on everything from mathematics to the meaning of life. He answered what letters he could, often with wit and humility. When a young girl wrote asking if scientists pray, Einstein responded, "Everyone who is seriously involved in the pursuit of science becomes convinced that some spirit is manifest in the laws of the universe, one that is vastly superior to that of man." When asked to define his religious views, he called himself a deeply religious non-believer, someone who felt a profound sense of awe and mystery at the cosmos but rejected the idea of a personal God. Chapter 13. The Final Equation. In April 1955, Einstein's health failed rapidly. An abdominal aortic aneurysm, diagnosed years earlier, began to rupture. He was hospitalized in pain, dying. Doctors suggested surgery, but Einstein refused. "I want to go when I want," he said. "It is tasteless to prolong life artificially. I have done my share. It is time to go." On his final night, April 17, 1955, Einstein asked for his latest calculations on unified field theory. The nurse brought him his papers. Even on his deathbed, he was still working, still searching for the pattern, the answer, the truth. During the night, he spoke some final words in German. The nurse didn't understand German. Whatever Einstein's last words were, they were lost. At 1:15 a.m. on April 18, 1955, Albert Einstein died. He was 76 years old. Following his wishes, his body was cremated, his ashes scattered in an undisclosed location. There would be no grave for pilgrims to visit, no monument to become a shrine. Einstein wanted to be remembered for his ideas, not his mortal remains. But before the cremation, the pathologist who performed the autopsy, Thomas Harvey, did something shocking. He removed Einstein's brain. Without permission from the family, Harvey took the organ that had revolutionized physics, photographed it, cut it into 240 pieces, and preserved them, believing that studying Einstein's brain might reveal the secret of his genius. It was a violation, a grotesque ending for a man who valued privacy. Einstein's brain would spend decades traveling in jars, being studied, measured, photographed. Scientists found some unusual features, certain areas slightly larger, others differently structured, but nothing that clearly explained his genius. The truth is, Einstein's genius wasn't in the structure of his neurons. It was in how he used them. It was in his willingness to question everything, to trust his own reasoning even when it contradicted the experts, to pursue beautiful ideas regardless of where they led. You can't find that in brain tissue. Epilogue. The Eternal Rebel. Today, Einstein is everywhere. His face is on posters, t-shirts, coffee mugs. His name is synonymous with genius. E equals mc squared is the most famous equation in the world. His wild hair and gentle eyes are instantly recognizable across every culture. But Einstein's true legacy isn't in his fame or his equations. It's in what he represents, the power of independent thought, the courage to challenge conventional wisdom, the willingness to follow truth wherever it leads, no matter how strange or uncomfortable the destination. Einstein proved that the universe is not what it seems. Time is not constant. Space is not fixed. Mass and energy are interchangeable. Light bends. The cosmos is expanding. Black holes exist. Gravity is geometry. Everything we take for granted about reality is just an approximation, a simplified version of a far deeper, stranger truth. He did this not with billion-dollar equipment or huge research teams. He did it with thought experiments, with imagination, with mathematical elegance. He showed that the human mind, properly applied, can decode the deepest secrets of nature. But Einstein also showed us the limits of genius. He spent 30 years searching for a unified theory and never found it. He rejected quantum mechanics and was wrong. He opposed the Big Bang theory initially and had to retract his opposition. He called the cosmological constant in his equations his biggest blunder, though it turned out to be necessary after all. Even Einstein made mistakes. Even Einstein faced problems he couldn't solve. Even Einstein lived with uncertainty and doubt. And that's the most important lesson of all. You don't have to be perfect to change the world. You don't have to be right about everything to be right about something profound. You don't have to have all the answers to ask the right questions. Final thoughts. The question that still echoes. Einstein once said, "The important thing is not to stop questioning. Curiosity has its own reason for existence." One cannot help but be in awe when he contemplates the mysteries of eternity, of life, of the marvelous structure of reality. It is enough if one tries merely to comprehend a little of this mystery each day. This is Einstein's true legacy. Not the equations, not the theories, not even the revolutionary discoveries. The legacy is the spirit of questioning, the commitment to truth, the wonder at existence itself. Einstein started with a simple question: what would it be like to ride on a beam of light? That question, asked by a 16-year-old dreamer, led to the realization that time and space are relative, that the universe is more mysterious and beautiful than anyone imagined. What questions are you afraid to ask? What conventional wisdom are you afraid to challenge? What impossible things are waiting for someone brave enough to imagine them? Einstein proved that reality has no obligation to match our intuitions, our common sense, or our comfortable assumptions. The universe is under no obligation to make sense to us. Our job is to make sense of it. He proved that one person, thinking clearly and courageously, can change humanity's understanding of existence itself. The boy who wouldn't speak grew up to explain the universe. The student who failed exams grew up to rewrite the laws of physics. The patent clerk grew up to become the most celebrated scientist in history. And he did it by never stopping asking why. Somewhere in the fabric of curved space-time, in the quantum foam where reality itself dissolves into probability, in the eternal equations that describe how matter and energy dance through the cosmos, Einstein's questions still echo. Time is relative. Space is curved. Energy and mass are one. Nothing can exceed the speed of light. Gravity is geometry. The universe is comprehensible. These aren't just scientific facts. They're invitations to wonder. They're reminders that reality is stranger and more beautiful than we ever imagined. Einstein gave us new eyes to see the universe. He gave us new questions to ask. He gave us permission to doubt, to question, to imagine impossible things. Most of all, he proved that the universe rewards those brave enough to question everything. So what will you question today? What impossible thought will you think? What mystery will you try to comprehend? The universe is waiting. It has secrets still to share. And somewhere, a 16-year-old version of you is lying in a field, looking at the stars, and asking a question that might just change everything. Ask it. The rebel who reimagined reality started with a single question. What's yours? The most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science. Whoever does not know it and can no longer wonder, no longer marvel, is as good as dead, and his eyes are dimmed. Albert Einstein.